How y'all doing today? My name is Bernie Thompson, and today we're here to take a look at this 2019 Ford EcoSport. This little EcoSport was in an accident about a year ago, and the front end was crunched, and the body shop replaced some components, and then they brought this vehicle over, and it was empty when the shop got it, and he tested it and everything looked good, and he charged it. And now 10 months later, it just started to get warm here again. It's getting in the 80s. The customer went to use his air conditioning, and guess what? The air conditioning doesn't get cold. So the customer brought the car back over here to see what's going on, and the shop checked it, and the entire charge is missing. It's leaked. Now that's an expensive charge in this new car. So that's $300 that just escaped right out of this guy's wallet. So we need to find where this leak is occurring. So the first thing we're going to do is we're going to let the machine go through and see if it can locate the leak. And I want to just show you guys something that you need to be aware of. Okay, so let's go ahead and run the machine. Okay guys, so what I want to do is I want to let the machine check this car to see if it's leaking or not, and if it's chargeable. So we think these machines are really smart. And they might be, but we need to be careful. So we're going to go ahead, we've put the amount that we need. We're going to hit charge. So we're going to go OK. Now we need to enter the amount of $7.5. We're going to say OK. So now it's going to check it to see if it can charge. We're not a high voltage system. The service hoses are connected. And so guys, I've never used this machine or a machine quite like this one. It's a really nice machine. Robinair makes quality products, no question about that. But look at this, we're checking vacuum leak test in progress. So the machine is going to check this, and it's going to tell me if I can charge this system or not. Is there a leak present or not? So obviously this car came in from the body shop. We're going to run it, and we're going to see if we can charge it, and then we're going to load the Freon in if it will allow it. So we're just going to let it run this test. I want the machine to make the diagnosis on what we need to do. And all I can say is that might be dangerous. Just be aware of that. But we're going to let it definitely see if it can find the leak. Now we know it's leaking because he charged it less than 10 months ago, and the entire charge is gone. There's nothing left in the vehicle. So this is a real world leak, because when I had my shop, this is the kind of leaks that would kill me. You know, we would look around, it'd come back, 10 months, 12 months later, and I'm looking for any kind of dye, and I don't see dye. I don't see any dye, or I don't see any oil traces. Especially in these new systems, there's just not a lot of oil circulated where you get oil traces. It's one thing you really need to be aware of on these newer systems. This isn't like in the old days. In the old days, I used to look around for the oil, and I could see where it was leaking because all the oil came out. On these new cars, that's not necessarily so true. Sometimes there's no oil trace and there's no dye trace, so we could look around the car and it may not show where the leak is. But the step one is I want to just see if the machine can tell me there's a leak or not. So we're going to just let the machine run through this. It's just running through a time check. And we can see here from the gauges we're putting it into a vacuum. So the machine is putting it into a deep vacuum, and then it's going to seal it, and it's going to see if we have a loss. And that will tell it if there's a leak or not. But guys, what's that going to tell me? That's going to tell me if I have a large leak or not. It's not telling me if I have a leak, it's telling me if I have a large leak. This can only test for large leaks. This isn't going to test for a small leak. This is like some hose that didn't get quite connected correctly and it's a big leak. But you know, an air conditioning system that held Freon for 10 months doesn't fall into that category. So you got to think about what the test is going to tell you. Okay, we're almost there, guys. Timer's almost done. Bingo. Now they're going to time it to see if the vacuum decays. So they built a vacuum over 5 minutes. Now they're going to see if it decays over the 5 minutes. And this will all be programmed, pre-programmed, and it would have to drop below some threshold that they programmed. The vacuum's going to have to drop. And we can watch these gauges and see if we've got a drop or not. But most air conditioning systems always remember that pressure is relative to volume. So you're going to have a rather large volume drain out. So to find this leak, it'd have to be a very big leak to find a leak doing this type of test. This is just making sure that you don't charge a system that has some huge leak and all your Freon comes rushing out. But be very aware that this leak test right here is not going to find a small leak. They're looking for large, really, really large leaks that would leak the vacuum out. And if you've got a really large leak, this is going to be great because then we don't start to charge it and all of a sudden hear it hissing out. You know, where all your Freon is going out, and that's all the money running right out of your wallet's going out. Because 1234 is some expensive refrigerant these days. Definitely something that we don't want to go into the atmosphere. So we can see vacuum leak test in progress, so it's testing it to see if it's leaking. Now guys, make sure you think about when something's running a test for you, think about what it's doing and how it's doing it so you don't get burned. Try to understand some of the tests that are automated, whether it's in a scan tool or an air conditioning machine or a scope. You have to sort of understand the basis of what's happening. And in this case, we built a large vacuum and we have a large interior to this system, so we have a high volume. Now to drop that vacuum, you're going to have to change that volume, which means you got to have a bigger leak. And if that doesn't happen, you could have a leak and you could charge the system and then the car's back within your year warranty and you eat the Freon. So just think about what you're doing. But in this case, this is a vacuum leak test where they built a vacuum, and if it's a little leak, if it's a small leak, guys, air conditioning leaks are small. Even, I mean, they're so small it's hard to believe. When you start to think about your detectors, these detectors will find a 4 or 7 gram per year leak. Well, if you've got a 7 gram per year leak, and this is a 1 pound system, it would take 12.9 years before you would lose 20% of your overall volume in this system. 12.9 years. Now, none of us are worried about that, but that's the sensitivity that's built into all these type of detectors. They'll find really, really small leaks. Now, obviously, this leak is not a 12.9 year leak. If it was, this shop wouldn't care, just like you're not really worried about it. But when it's a 12-month leak, you better be worried about it, because then that money comes out of your pocket, not the customer. I mean, most shops warranty their work for 1 year. If the Freon can't stay in there for a year, you're paying for it. So we got to think about these kind of tests and what they're doing. So the detectors will find really, really small leaks. Like I say, a 7 gram per year leak will take 12.9 years to just leak 20% of the charge off. That's where you just start to feel a performance issue from an air conditioning system. So they'll find extremely small leaks. But a vacuum test like this, it has to be an extremely large leak for it to locate any kind of leak with this type of testing. So even though this machine may find this or may not, we're going to see, because we're going to see how big this leak is. If it's a really, really big leak, the machine won't charge the system because it will have lost vacuum. But if it's a pretty small leak, like one that could leak out in 10 months or a year, this system, this type of test will not find that type of leak. But your wallet will find it when you're paying for the $1234 when it all leaks out. So we don't want that. Okay, we're coming up, we're clocking it, we're almost to the end of the test. So it's going to pre-charge it for a leak test, and is what it's going to want me to do is to see now if so we're putting a real small amount of refrigerant in, so it thinks that there's no leak in this system. That's why it charged this. And now it's going to tell you that it wants you to check the evaporator in the dash and to get your leak tester out to see if this is leaking under the dash. Because really what it's, I guess it's considering that that's our best leak chance. So we're going to go ahead and confirm. We didn't find anything under the dash when we went and looked. Okay, so we're going to say that there was no leak found with our leak detector under the dash, because there wasn't. Okay guys, so now this is going to charge this system now, so I want to stop that. So we're going to stop this. I do not want that to happen. We want to abort, so we're going to hit escape. I do not want to do that. So what the charge amount that was put in here, we want to go ahead and recover that. So we want to cancel it, and now we want to go ahead and we're going to recover that. Whatever was in here, we're going to recover. And again guys, I've never used this machine. I don't know anything about it, but I have an idea of physics and how volumes and so on work. So I understand how someone would write the code in order to make a machine like this work. So now it's going to identify to make sure that this is pure 1234. And this is another big piece, guys. Okay, one thing that you got to know about these machines when it checks the recovery to make sure that this is 1234, it has to have more than 15 pounds to do that. Every machine, every 1234 machine has the same problem because the same identifier is used in all these machines. One company has a patent on it, so that patent technology is patented, so the same identifier is in every one of these machines. So when it drops to 15 psi, the rest of the charge is dumped to the atmosphere. Depending on the size of the system, you're going to lose between $10 and $30. Like if you've got a large truck or one of the ones where I've got a double air conditioning front and rear, when it gets 15 pounds, it's going to dump that to the atmosphere because it can no longer test to make sure the identity of the refrigerant is pure. Now that's a costly thing. So when you charge these systems, every time you recover it, you lose Freon. And you got to be aware of that because you got to charge for that. Every machine is going to drop about the last 15 pounds of pressure. Doesn't matter who makes it. So just be aware that every time you recover the charge, you've lost money. And there's nothing you can do about it. It's just part of how the machines are made. So that's a crazy, crazy fact, but be aware of it because this is expensive refrigerant, and if I dump the last 15 pounds off of large systems, it can be really expensive. Okay guys, we're going to use the BULLSEYE by ATS, Automotive Test Solutions. This is a CO2. We're going to put CO2 in the system, and CO2 is pennies an ounce, not dollars. So it makes a huge difference when we're trying to find a leak. I'm going to use the high pressure regulator, and we're going to put this on our bottle, and I'm going to get the YF hose so we can fill it so we can charge this system. So let's go ahead and get this set up and get it on the car. Okay guys, so what I want to do is I want to use CO2. I'm going to charge the system with very inexpensive CO2, pennies per ounce, not dollars per ounce. And then I'm going to be able to find the leak. And if a bunch of it leaks out, it doesn't matter. And we know that this is a pretty good leak on this car because it leaked out in 8 to 10 months. That means it's a larger leak to lose the whole charge in that kind of time. This isn't some super small leak, because a super small leak would take years to leak. This leaked in under a year. This is real world, guys. This is the kind of problem I fought at my shop. That's why I invented this system, because I owned a shop for 27 years and I would charge a system and it would be back within the year, and then I'm having to pay for it. And the dyes just don't work. They're very poor. The other thing with ultraviolet dyes that you guys need to know about is if the dye comes out and it's out in the atmosphere where a lot of ultraviolet light can hit it, it won't stay fluorescent. It'll only be ultraviolet for maybe 2 weeks, and then it starts to lose its ability to be ultraviolet, ultravescence. So it's real important to understand that if you've got the dye in there, you've got to find it within a few weeks, so don't get the car back months later and all of it's gone, because then that dye may not be ultravescent. Some of the dyes last longer than other dyes, but many of the dyes that you guys will use only stay really active, and you can see in ultraviolet light, and they might only shine like that for a few weeks once it's leaked. So you can actually have a dye leaking, and then you can't find it with the light. The next thing you got to think about is the dyes are moving through these systems with the oil charges, but these new systems don't move oil around like the old systems. That's another reason, like when you start looking at the hoses and so on, you can't really see oil all over the hoses because it doesn't lose a lot of oil. I mean, some of them do, but these leaks are so small on these new systems because when they made the rule changes, they said that these hoses can't leak. And so they barely will leak anything. And some of them are bad and they'll leak way more, but you just don't have the same amount of oil running through the system to where that oil comes out and will carry the dye with it, or you get an oil trace. I remember in the 70s and 80s when I was doing this work, we just looked for the oil, and I could tell you where the leak was just by finding the oil. These new systems are not like the 70s and 80s. The whole system is made quite a bit different, so it's going to be much harder to find leaks. So what I want to do is I want to charge this with the CO2. I've got my regulator adjusted to 200 pounds. Now guys, let me assure you, I've dealt with the OEs and multiple OEs. The most you can put into an air conditioning system as far as pressure goes is 200 psi. If you exceed 200 psi, you stand a chance to damage the evaporator core. A lot of these evaporator cores are made like an accordion, and when they go over 200 pounds, you stretch them, and now you just made that leak. It won't leak right now, but it'll leak later. Now you caused your customer a core leak because you didn't do the right testing procedure. As far as I'm aware of, no OE will allow you to put more than 200 psi in these systems, whether it's with nitrogen or CO2 or anything else. So save yourself and your customer from having a problem. 200 pounds is maximum. My regulator limits you at 200 where you cannot go higher, and it's made like that on purpose. So that matches the OE. So now we're going to go ahead and charge this thing. And I want 200 pounds in it. And now we're going to be able to find a very cheap gas, because I mean, if this is leaking ounces by the time I find the leak, I could already lose $50 or $100 if I'm using YF. So why would we do that? It's just not a good way to do leak testing. This is also more effective because I have a higher pressure. If I've got YF in there, I am dictated by the ambient temperature of the day. In other words, if it's 60 degrees, like right now, I can only have 60 pounds in this system because refrigerant reflects the ambient temperature. It's one of the properties of it. So if it's a hot day, you're going to have a better chance to find it. Why deal with that? Be able to use a detectable gas like CO2 that I can have 200 pounds in rather than a detectable gas that's at 60 psi. Because always be aware, the orifice size by the pressure is what volume is set by. So the more pressure, the more volume comes out. That means it's an easier way to find that leak with your detector. I want the maximum amount of pressure that I can have. And in this way, I don't have to run the motor and have fans and belts running to where it might move that refrigerant away where I can't find it. I can have a dead still. When you look for leaks, you need a dead still environment. We don't want fans blowing or air conditioning fans. We don't want the air moving, and we don't want the engine running. This is a really good way to accomplish that. So we've got this guy charged to 200 pounds now. So what I want to do now is we want to get this off. And regardless of what gas you're going to use, always take your thing off, your hose off, and then always blow out around this fitting. Because whether you have YF in here or you have CO2, there'll be gas down in here. And I want to check these Schrader valves because a lot of times after you charge it, I could have a Schrader valve leaking maybe, and that's where my loss came from. So I always want to check that valve. So that being said, now I need to get my detector on and get it warmed up so I can find this leak quickly. Okay guys, I got the detector. And let's just make sure it's working. It's hot. So I can breathe, and we can see it pegged it. So you breathe out CO2. So when you're doing this type of work with CO2, don't be breathing on the area you're checking, like heavily breath. Keep your breaths real short when you're doing this work. Now I'm going to come in and I want to test this fitting. There's nothing there. We want to test this fitting. Always test the fittings first because I've found so many leaks at the fittings it's unreal. Okay, now this car was hitting the front and they probably replaced this condenser. So I just want to go where I think it might be first. Let's just check these fittings right here. And there's another one right down here. Okay, so neither of those fittings right there is leaking where the condenser bolts in. So what I want to do now is I want to just check the condenser up in the front. And I don't have to move super slow because I know this is a bigger leak. I know it's a bigger leak because this leaked out in less than a year. And it leaked the entire charge. The smaller the leak is, guys, the slower you got to move the probe. So if you've got some small leak, you cannot do what I'm doing right here. You got to move real slow with really small leaks. Okay, that's the leak right over there. I had full bars come up, but let it clear, pull it out, let it clear. Now change your setting to medium. We found a real sensitive. Now I want to see how big the leak is. If it finds it on medium, okay, that found that leak, no problem on medium. Pull it out and let it clear. This is a much bigger leak. This isn't a super small leak, just like I thought. Okay, it's leaking right down in this lower left corner on the condenser is what's leaking. Positively got a leak. And notice I changed my sensitivity. Now we're going to change the sensitivity. Once it clears, only change it once the lights are off. If you change the sensitivity with CO2 in here or a refrigerant detector, you re-zeroed the thing and then you have something in there. So we're going to do it on really low. This is going to tell me how big the leak really is. If it goes off now, it's a huge leak. And I don't think it's that big a leak or the vacuum would have found it. See, it's not going off now. Now, even though it's not going off, let it clear before I change it. Now I'm going to go back to medium. Okay, that's a pretty good size leak, and it's right up here on the lower driver's side corner of that core. Okay guys, what I want to do now is I want to look for that leak with ultraviolet light. All OEs put ultraviolet dye in these systems, especially YF, because if it goes back under warranty, they want to find it. So let's see if we can find that with an ultraviolet light or not. Okay guys, so I've got an ultraviolet light, and we're going to come in and we're going to look down on that corner where it's leaking, and we can see there's nothing glowing there at all. So I don't see dye. Now all OEs put dye in. Okay, now there's a whole nother thing we need to know about. Super, super important right now. Okay guys, the one thing that you guys need to understand is the UV light has to match whatever dye is in the system. The frequency from the UV lights are different, and they've got to reflect the UV that whatever the dye is in the system. So in order to prove this, what I want to do is I want to take this. We just pulled whatever was out, and we've got some oil in here. Okay, there's hardly any oil in there. Okay, so there's hardly any oil in there, but I got a little bit out. So this doesn't ultravest the way I'd expect, but it does have some ultravescent property. And if I had a different frequency, it might really shine in ultraviolet, but I can see, I'll at least be able to see that. So if that core, if this was on the core at the leak site, I would have seen that with this light. Now I cannot see anything on that core when I look at the dye. But I can tell you I've been looking for dye for 40 years, and it's just a very poor visual indicator for a leak. That's all I've ever figured out, is it just doesn't really work. So this, we can see it somewhat ultravescence, but not as much as it should, but at least I can see it. And all these new cars are going to have some kind of UV dye in here, especially in YF. So I do have dye, and I also know that if the dye is leaked and it's in the environment and it's leaked a couple of months or a couple of weeks earlier, it will lose its ultraviolet capability. The longer it's in sunlight and in the environment, the less it has ultraviolet. And you can see this doesn't have a very good ultraviolet property anyway. So if this does leak and then it's in the sunlight, it's going to ultravest less. So you got to be aware of that. You know, dyes are just a really poor indicator, and we already all know that. We've all looked for dyes our whole career. I mean, I can remember a lot of cars I had to fix the air conditioning and I couldn't find the leak. Dyes don't show it. I couldn't find it with the detectors. So, you know, then when I look over the whole system and it comes back and I still can't find it, oh, so it's the evap core. So then I go look it up in the book and I see, you know, it's a 10-hour job. And now we're well over $1,000 to put the core in there. So no, I'm afraid to call that, because once I put the core in, I'm married to that car, and whatever is leaking now is on me if I'm wrong. Let me tell you a better way to do that, guys. CO2 is heavier than air. So pressurize the system to 200 psi. Now right away we have a major advantage with CO2, because CO2 is a detectable gas in the atmosphere. Nitrogen, you can't detect it, it's worthless, because 80% of the atmosphere is nitrogen. So if you put nitrogen in a system and you start looking for it, how are you going to find the leak? And if it's a really small leak, it's not going to blow bubbles, guys. It has to be a really big leak to blow bubbles. You know, or you just keep upping your pressure until you blow or damage the system. You know, I had one technician that worked for me, and he just kept cranking the pressure up because he couldn't find the leak. And I was up in the front office, and all of a sudden you hear BAM! And I went running out. Oh, he found the leak all right. The evap core was leaking. So now I'm putting an evap core in on me. And man, we don't want to do that. You cannot use more than 200 pounds pressurizing any system, or you might have a really bad day. We don't want to have those kind of days. So just make sure you keep your pressure under 200 pounds and you won't blow anything up in the system. And I'm getting this direct from OE Engineering. 200's max pressure. But once I charge the system to 200 pounds and I plug the drain line, the CO2 will leak out in this area, and it will fall because it's heavier in air, and it will take the same drain path as the condensation, and it will accumulate at the drain hose. If I have it plugged and I leave it charged at 200 psi for a couple of hours, and then I pop that plug out of the hose and put the sniffer in there, if it goes off, you got a leak inside your evap housing. It's that simple to accurately diagnose these. There's all kinds of new technology, guys. I struggled my whole career. That's why I designed and built this system. Because, man, air conditioning leaks can be really, really complicated to find. Do it the easy way. Don't fight it. Okay, guys, the foam really works well to find exactly where the leak is. It gives you a second indication to prove the leak site. If you spray the foam on and it changes color right away, and the whole foam is changing, that's what the wash is for, guys. There's acid on wherever you're spraying it, there's acid. Take the water wash and wash it off, and you don't even have to let it dry. Once you wash it, then spray the foam on, and you'll see that it won't change the whole foam color right away. That's why the wash is part of the kit. Okay, we're going to use the BULLSEYE. It'll change color. Make sure you have the straw on it or it won't work right. So now you just wait a second and we're going to watch to see where that changes color. Okay, you can see it changing color in the lower left-hand corner of the condenser. You can see where it's yellow. That's the leak site, so the core is definitely leaking. The advantage of this is it gives you a double way to find it. I found it first with the detector, and I've proven where the leak is with the foam. This is a huge advantage to have a second testing mechanism to find that leak. Okay, guys, we all know how difficult some leaks are to find. I mean, sometimes leaks are really complicated to find. This technique just makes it way easier to be accurate and know that the car's not going to come back and that you found the leak. This little Ford, they'll get this fixed. They're going to need to put a condenser in and then they'll charge it. Well, they'll put the condenser in and then they'll charge it with CO2 and make sure you check it. If you're doing this in your shop, you want to charge it and go around the system. Check the whole system. I mean, I knew the car was hitting the front, so I just wanted to check the front first. I wanted to do this the easiest way I could. And I also knew that it had lost its charge in 8 months, which means it's a pretty good leak. When you got really small leaks, guys, you're going to have to move the probe really, really slow. If you try to move it like you saw me, you will never find the leak. Always know how big the leak is and keep that in the back of your mind when you're going around looking for it, and you'll always be successful finding leaks in your shop too.